Alright, Chapter 8 mid-chapter review. Graph each function. Y equals 6 to the x power. So for x, we're going to pick some numbers on each side of the y-axis. So -2, -1, 0, 1, and 2. So 6 to the -2. Well, what's 6 squared? 36. So negative, we're just going to make it 1 over 36. Alright, 6 to the -1 would just be 1 over 6. 6 to the 0 would be 1. 6 to the first is 6. 6 squared is 36. Should be easy to plot these points. When x is -2, y is 1/32 or 1/36. When x is -1, y is 1/6. When x is 0, y is 1. When x is 1, y is 6. 1, 2, 3, 4, 5, 6. And when x is 2, it is 36. Okay, this is enough for us to graph exponential growth. The biggest thing is make sure it's crossing at the 0, 1. Okay, and we're going to have an asymptote of y equals 0. Okay, next example. The world population in 2000 was approximately 6.08 billion people. The annual rate of increase is 1.26%. Part A, find the growth factor. Well, the growth factor is our b in our equation, which is 1 plus r. Well, our rate is 1.62%, which we can convert, or we must convert to decimal, which would be 0.0126. So b is just going to be 1 plus that, 0.0126. So our growth factor is 1.0126. Hopefully that was pretty easy for us to see. Okay, so part B says this. Suppose the rate of increase continues to be 1.26%. Write a function to model the population growth. Well, y equals ab to the x. So y equals a. Well, in 2000, what was our population? 6.08 billion. So 6.08 times, what's our growth factor in 2000? 1.0126 raised to the years after 2050 or 2000, so we can say x minus 2000, and that's going to get us an exponential growth function. Okay, next problem. Write an exponential function y equals ab to the x power for the graph that includes the given points. Now in your test, I may give you a graph and have points highlighted. So we have the function y equal ab to the x power given. So step 1, we're going to use the first 2 points. So that's xy. So 8 will equal ab to the 4th. We're going to solve for a. So we're going to divide everything by b to the 4th. So we find out a equals 8 over b to the 4th. Now we're going to use the second equation, or the second set of numbers. So again, we have y equals ab to the x. Well, our y value is 32. Our a value, well, we're going to use this a value. So 8 over b to the 4th. And then it's going to be times b to our x, which is 6. So don't forget, we can simplify our b's. B to the 6th over b to the 4th is really b squared. Okay, that's just a little side note. So we can rewrite this as 32 equals 8b squared. Well, now we just solve. Divide each side by 8. So we get 4 equals b squared. So b must equal 2. So now we're going to plug that back into our equation and solve for a. So if a equaled 8 over b squared, or b to the 4th I should say, it's going to be 8 over 2 to the 4th, which is going to be 8 over 16, which is going to be 1/2. So now we've got to write an equation. Well, the base equation is y equals ab to the x. So now I have an a value and I have a b value. So y equals a, which we already solved to be 1/2, times b, which we solved to be 2, to the x power. So there's our work. That's how we solve. Make sure you can do this. This is a good one to study. Okay, next example. A computer is valued at $6,500, depreciates at a rate of 14.3% per year. Write a function that models the value of the computer. Well, y equals a bx. Well, what is our b? 1 minus our rate in this example. So that would be 1 minus 0.143, which would give us 0.857. So y would equal our a value. What was the initial value of the computer? $6,500. What's our rate of decay? 0.857 to x power. So that's a. There's our function. Easy enough. B, we just got to plug it in after 3 years. So it's going to be y equals 6,500 times 0.857 cubed. All right, so plug it in our calculator. 6,500 times 0.857 to the third power. So $4,091.25. $4,091.25. So that's how much the computer is worth after 3 years. Next example. Phosphorus 32 is used to study plants' use of fertilizer. It has a half-life of 14.3 days. So write an exponential decay function for a 50 milligram sample. So we know y equals a b to the x. So y equals a. Our sample size was 50. B, well, it's a half-life, so our rate of decay, or our decay factor, is 1/2. Okay, now it says the half-life is 14.3, so remember, that's going to be the denominator, and the numerator is going to be how many days they want us to evaluate it for. So 84 days. So let's plug it in the calculator. So we get 50 times 0.5 raised to the 84 divided by 14.3. Close parentheses, enter. 0.852. So y is equal to 0.852 milligrams. Okay, well, it goes through 6 half-lives, so that makes sense. That's pretty good. Okay, next example. Oh, another half-life one. So iodine 131 used to find leaks in water pipes. It has a half-life of 88.14 days. Write the decay function for 200 milligrams after 72 days. So y equals, well, our sample size is 200. Our decay factor is 1/2. We're evaluating after 72 days with a half-life of 8.14. So 200 times 0.5 raised to the 72 divided by 8.14. This should be a fairly small number. 0.435. So y equals 0.435 milligrams. And that makes sense. There's almost 9 half-lives in there. So if you divide 200 by 2 9 times, you would get 0.435. Okay, next problem. Find the amount of interest. Find the amount in a continuously compounded account. So continuously tells us, hey, we're going to use A equals PER raised to the RT power. Okay, so let's look at the first one. A equals, my principal is $2,000. My interest is 0.051. Remember, you got to convert it to decimal, times 3. That's just easy calculator work here. So that's just 2,000 times E 0.051 times 3. 233,065. 2330.65. All right, next one. Same equation, A equals PE to the RT power. So A equals 400 times E to the 0.076 times 1.5. Again, that's easy calculator work. Just plug it in. So it's just going to be 400 times E to the 0.076 times 1.5. This shouldn't really be that much. $448.30. So $448.30. Okay. Last one of this type. Okay, this one's 10 years, so this one should be, fairly big number. So again, A equals P times E to the RT. A equals, the principal's 950. The interest is 0.065 and the time is 10. So again, we can just plug this into the calculator for easy work. 950 times E times 0.065 times 10. 1819.76. 1819.76. Okay, easy stuff. Continuously tells us to use PERT. Okay, so a student wants to save $8,000 for college in 5 years. How much should be put in the account that earns 5.2 annual interest compounded continuously? So again, we should use A equals PERT. So they want to save $8,000. So that's not what we're going to invest. That's what we want out of it. So that's our A value. So we're going to put 8,000, okay, equals P times ERT. So we're given rate and we're given time. So what are we solving for here? We're solving for the principal. We're solving for the principal. So let's set the equation up before we plug it into numbers. So if I have A equals P E to the RT and I'm solving for P, I'm going to divide each side by E raised to the RT power. So my principal is really going to be A over ERT. Okay, just dividing everything by E raised to the RT power. So let's look at it. Principal is, my A value is $8,000 over my E to the 0.052, and I need to save for 5 years. So there's my equation. So that's easy calculator work for us. So let's just plug it in. So I got 8,000. We're going to divide that by some parentheses. The exponential of 0.052 times 5. $6,168.41. So 6168.41. 6168.41. So that's how much we need to invest right now if we want to have $8,000 in 5 years. Okay. Study this one. There's one like this on the test. Suppose you invest $2,000 at an annual interest rate of 4.5% compounded quarterly. How much do you have after 5 years? So this one is a little bit different since it's compounded quarterly. So A equals the principal times 1 plus the rate over how many times it's compounded times years and the number of times it's compounded. So it's going to be $2,000 times 1 plus 0.045 over 4 to the 4 times 5. Okay, 2,000 was my principal, 4.5% is my interest rate, 4 was its compounded quarterly, so 4 times a year. So let's do the work. So I have 2,000 times 1 plus 0.045 divided by 4, close parentheses, raised to, in parentheses, 4 times 5, bam. So 2501.50.